So how do we prevent workplace accidents from slips, trips, and falls? There are many preventative steps that we'll discuss that you and your water utility may already be doing. If not, you'll want to add these to your daily routine. There are also some good reminders here for all of us who want to maintain the very best utility safety program possible. Let's begin by looking at how these incidents are categorized. Falls are categorized as either same-level falls or elevated falls. The majority of injuries from falls, primarily due to slips or trips, take place on the same level. Surprisingly, 60% of the elevated fall injuries are from falls of 10 feet or less. So it's certainly important to take precautions when working on high structures such as water towers. But it's also important to be careful when we're working much closer to or on the ground. Many of the injuries that take place close to the ground are a result of slips and trips. Slips and trips are many times caused by two seemingly simple factors: an irregularity in the pathway of a worker and inadequate awareness to those irregularities on the part of the worker. Workers, their supervisors, and utility safety programs share the responsibility of controlling those factors. Good housekeeping practices and the installation of slip-resistant flooring wherever possible are the first lines of defense. But often, slip hazards exist beyond those controls. Slips, both forward and back, are primarily caused by slippery surfaces and inadequate footwear. There are many potential slippery areas that utility workers may encounter. For example, puddles of water leaking from pipes, spills of chemicals, grease and other slippery materials, waxed floors, wet and muddy trenches, and other exterior work areas, weather hazards such as rain, snow, and ice, gravel on pavement, and deteriorating or crumbling surfaces such as concrete. Sometimes it's possible to minimize the risk by adding ingredients to the slippery area, such as adding sand to ice, or by removing the slippery hazard, such as cleaning up the spill, or by sweeping gravel off pavement. But in other cases, traction is the only reasonable measure to counteract these slip hazards. There are many types of work shoes available on the marketplace today. Some are certainly better and safer than others. So how do we know what to wear? Safety experts suggest that we look at two factors when we purchase our slip-resistant footwear: tread design and tread material. Slip-resistant is a specific term used by shoe manufacturers to indicate a shoe reduces the likelihood of slipping. Any shoe called slip-resistant should have test data supporting that claim. However, most manufacturers conduct their own unique slip-resistant testing.
Back injury prevention starts before you ever begin to work. It starts with a good warm-up stretching routine. Just as athletes don't jump into their activities without warming up, neither should we. Muscles need to have time to stretch and wake up, and we do this by increasing the flow of blood to our muscles.
Making sure that before you start into some physical activity, that you've got your blood flow going, because if you just wake up and roll out of bed and go to dig a hole, your blood flow slows down considerably at night, and your working tissues don't have a lot of that blood, and you have, again, less flexibility, less pliability, more chance of stress or strain.
A specific exercise or stretching routine should be conducted with the approval of a physician. And while on the topic of stretching, don't limit it to the start of each day. It's important to continue stretching during breaks and prior to resuming work after lunch or any time your body has been sedentary for a while.
Exercise wakes up and activates the body to produce energy, so many shift workers use exercise to help them get ready for their shift. 20 minutes of aerobic exercise, such as jogging, a bike ride, swimming, or time on a treadmill, is a good lead-in to your shift. Be sure and pace yourself. Too much exercise before work can leave you tired during your shift, especially if your job includes physical labor. Some shift workers use exercise to help them move from one shift to the other, moving their workouts from morning to afternoon to evening to parallel the work schedule. Stay active on your days off. A couple of days of sitting around watching TV won't help you when it comes time to go back to work. Although exercise is a great way to help get ready for the shift work, don't let it interfere with your sleep. Avoid exercising in the hours just before you go to sleep.
The next area we'll look at is diet. If you read the papers or watch TV, you know there's always some new report out touting this food or that as a cure-all for everything from insomnia to baldness. We're not going to make specific recommendations because everybody's body reacts a little differently. We can, however, offer some general guidelines.
Stick to a diet that, along with your exercise routine, helps keep you physically fit. Stay away from foods high in fats and sugars that can lead to excessive weight gain. Leading into your shift, stay away from heavy or spicy meals that are difficult to digest and leave you feeling full and slow. During the shift itself, many workers have found it best to eat light since our body has a little more difficulty digesting food in the middle of the night. Snacks and meals that include fruits, vegetables, and high-protein foods seem to work the best. High-sugar foods such as candies and pastries may seem to give you a short burst of energy, but probably will leave you tired later in your shift. Tracking the foods you eat both before your shift and during it, and making note of how your body responded to them, will be a key segment of your night shift journal.
And finally, what can you do while actually on the job to make that shift work go a little smoother? Here are some tips that may help get you through the night.
Drink plenty of fluids. Body functions slow down at night, and workers reduce fluid intake, which can result in mild dehydration. When possible, avoid performing the heaviest and most dangerous tasks in the middle of the night and early morning hours. This is when your energy or circadian rhythms are lowest. Some jobs, especially those such as monitoring a control room, don't require much activity. Keep your mind and body moving as much as possible. It will help you stay alert. If you start to get drowsy, take immediate steps to counteract it. Get up, stretch, move around, get your heart pumping. Some facilities have exercise equipment on site to help. Just a few minutes of aerobic activity during a work break can help you get going again.
Water treatment facilities use a wide variety of chemicals in the daily task of providing clean, safe drinking water to customers. All of those chemicals have to be transported to the treatment plant, received by water utility employees, and then appropriately stored until needed. It may seem like a simple, straightforward process, but because many of these chemicals pose a health hazard to the public and the people transporting, receiving, and storing them, great care must be taken each and every step along the way. If not, a number of serious issues can take place. For example, the wrong chemical can be pumped into a storage area or container. Incompatible chemicals may accidentally be mixed together, resulting in a toxic combination. The storage area may be too hot, humid, or contain materials that could ignite the chemical being stored. Inadequate safety considerations for employees and the public can result in injury, death, and extensive damage to property. It's also important that the quality of the product received at the treatment facility reflects the standards and specifications set by the utility when purchased. There are security issues that also need to be addressed when transporting and receiving chemicals, from making sure that only authorized personnel are involved, to maintaining accurate inventories to help detect any theft of goods once they are at the treatment facility. And finally, all of these procedures must comply with local, state, and federal guidelines. Here are some suggestions for basic requirements for bid or purchasing documents. Purchase and use only chemicals that meet AWWA standards. Chemicals should also be certified to NSF Standard 60 or equivalent. If there are no applicable AWWA or NSF standards, require the chemical to meet an American Society for Testing and Materials, or ASTM, or another chemical industry standard. Because some state regulatory agencies require certified chemicals, be sure and check with your regulatory authority to make sure you are in compliance. Include in your purchasing and bid documents the hours and days of the week qualified employees are available to receive the shipments. Make sure to include enough unloading time in the schedule so samples can be provided and testing completed. Require a load-specific certificate of analysis. Clearly identify who will be responsible for getting a sample of the shipment: delivery driver or plant employee. Chlorine and all of the chemicals mentioned in this video, in addition to others used in water treatment, must be handled and stored according to manufacturers' recommendations, utility SOPs, and local, state, and federal regulations. Water treatment chemicals are very safe and effective when handled appropriately by trained distributors and utility workers.
Various types of saws, particularly power saws, are important tools allowing us to complete certain jobs here at the water utility. However, these tools also require specialized training and maintenance so that workers can operate them safely. Saws are used every day on water utility job sites, from simple hand saws to powerful cutting machines. Although the various types may be quite different, they share some common hazards and the requirement for safety precautions. This video focuses on the use of power saws used to cut various types of utility pipes and those used to cut pavement or concrete to access underground work areas. The first step when selecting the most appropriate cutting tool is to determine what saw and blade will provide the proper result once the cut is complete. That is primarily based on the material size and hardness to be cut. Using a saw or blade not designed to efficiently cut through a material will usually damage the tool and create a safety hazard for its operator. Industry standards and manufacturer recommendations help utility personnel determine what saw works best in water utility applications. It's best to follow specific manufacturer recommendations and OSHA standards for each job task. Here, though, are some general guidelines to be aware of. Many common blades are named specifically for the material they are designed to cut, such as masonry, wood, PVC, and concrete or asphalt. Generally speaking, the more teeth per inch on the blades, the cleaner the cut. Grind or finish blades have teeth that work to slice the material and thus result in a cleaner cut. Blades with fewer teeth are capable of cutting thicker material. Rip blades cut fast at high feed rates, but do not make smooth cuts. A non-ferrous metal or plastic cutting blade is used for aluminum, brass, copper, lead, and most solid plastics. Carbide-tipped and diamond blades are more expensive, but require less frequent sharpening and make the smoothest cuts. And a reminder that using power tools to cut asphalt cement pipe is prohibited by law. In addition to general utility safety training, anyone using these saws should have specific tool training and have read the entire operating manual and manufacturer's guide for each different saw used on the job. Operators should also review these documents prior to each use. Like so much else we do out in the field, operating a power saw safely depends on several key factors: having the right equipment, knowing how to operate it, and then taking some extra time to make sure that all safety precautions are being followed. Electric shock is a danger water utility workers face during the installation and service repair of water pipes and meters. Water pipes are often used to ground electricity in homes. If there's a fault in the electric system, the pipe and distribution component can be energized with electricity. A severe or even fatal shock can occur if enough electricity is present in the pipe or meter. According to an AWWA study, more than 350 significant distribution system electric shock incidents occur annually to water utility workers. A much larger number of minor shock incidents occur each year, many going unreported. This video looks at the electrical grounding issues that affect water distribution systems and what workers need to do to work safely on them. Let's begin by looking at how electricity works, so we'll have a better understanding of when and where a potential danger is most likely to exist. Electricity always wants to return to its source to complete a continuous circuit. A typical circuit has two conductors, one that flows from a service panel to an appliance and one that returns the current to the panel. A neutral wire and ground wire are both connected to electrical ground. The neutral wire completes the electric circuit by conducting current away from the plugged-in electrical device. The ground wire is a safety device that carries electric current away from a device when the circuit or plugged-in device malfunctions. Grounding wires are connected to all outlets and metal boxes and then down to the earth by attaching it to either a metallic rod that travels deep into the ground or a water pipe. Poor insulation or a faulty neutral may allow the current to pass through the ground. The shock to utility workers occurs when they install or remove a water meter or cut through metallic pipes connected to the faulty ground. Here is how electricity grounds through humans. Electricity travels to the earth, always looking for an easy path to ground. Electricity passes very quickly through our bodies when we come in contact with it. The voltage and current of the circuit and internal body resistance will determine the severity of electrical contact. In some cases, electricity uses multiple paths to ground. The operator may get shocked when first touching a pipe or service meter. An operator may also get shocked when reinstalling a meter or service line because the operator completes the ground circuit. OSHA designates a shock hazard if the potential is more than 42.4 volts peak and the current through a 1500 ohm load is more than 5 milliamperes. 1 milliamp of electricity creates a tingling sensation. 9 milliamps will cause muscles to contract, making it difficult to let go. 17 milliamps and above can cause extreme pain, respiratory arrest, and severe muscular contractions, and in some cases, death. 100 or more milliamps are capable of stopping the heart, inhibiting breathing, and blocking the nerve center to the brain. Electrical injury can cause arrhythmia that can be fatal hours after contact. There are a number of noisy jobs and settings at a water utility, but a noisy setting is more than just uncomfortable for anyone working here. It's dangerous. It's a safety risk because not only is it difficult to communicate, but all of us working in this area are subject to the serious problem of noise-induced hearing loss. Work-related hearing loss is a concern for many companies, organizations, and their employees, including water providers. According to the National Institute for Occupational Safety and Health, 30 million workers are exposed to hazardous noise on the job. At present exposure limits, it's estimated that 1 in every 4 of these workers will develop permanent hearing loss, making hearing loss the most common occupational disease in the United States. While excessive noise is the most significant contributor to the workplace hearing loss, research has shown that exposure to certain solvents, metals, and carbon monoxide is also a factor. The average healthy person should expect normal hearing at least to the age of 60. However, this is not the case for workers exposed to excessive noise. Noise-induced hearing loss is completely preventable, but once acquired, it's permanent and irreversible. We measure noise in units called decibels, or dBs. Quiet conversation is about 60 decibels. A jet engine or loud gunshot, about 140 decibels. But let's look at decibel levels for noises we're likely to be exposed to at a water utility. A lawnmower, 90 decibels. A backhoe or front-end loader, 85 to 95 decibels. Circular saw, 90 to 100 decibels. A loud generator, 100 to 110 decibels. A jackhammer, 112 decibels. The decibel level at a utility will vary according to the type of equipment used in it. By using a sound level meter, we can determine that the decibel level in this room is 92 dBs. And that's an important number to know because OSHA has identified permissible noise exposure limits for workers without hearing protection, or just how long you can subject your ears to a certain decibel level before there is permanent ear damage. It's time to talk about the specifics of personal protective equipment. In this case, hearing protection. And let's say this right up front, sticking cotton in your ears is not approved hearing protection. Let's take a look at what really does work. The first thing to know about all approved hearing protection devices is they are clearly marked with a noise reduction rating, or NRR number on the package. The higher the number, the better the protection. The three main types of protection are earplugs, ear caps, and ear muffs. Earplugs are made of foam, plastic, or rubber. Some come with strings attached to keep them around your neck. Take care to keep earplugs clean to minimize irritation of the ear. To insert a foam earplug, roll it between your fingers or in the palm of your hand until it's half or less its regular size. Reach across your head with your opposite hand to grab the top of your ear, which will open the ear canal. The foam plug will expand open when you release it. Insert plastic and rubber earplugs in a similar manner. Canal caps resemble earplugs but don't extend inside the ear canal. They are connected with a plastic or metal band that holds them firmly in place. Ear caps only reduce noise to the ear by about 10 decibels and primarily are used for temporary ear protection by workers who are not exposed to extended periods of hazardous noise. What are the 5 most dreaded words you can tell a water professional? Fill out the paperwork, please. Sometimes it seems like we spend more time shuffling papers than anything else. So when somebody tells us to fill out a report about an accident or a safety problem, let's face it, it seems like a pain in the... You know what? Well, it's my job to put a positive spin on those 5 little words, so here goes. Might help if you understand what these safety reports are used for. They serve 2 purposes: to form a better accident prevention program in the future and gather the information necessary to take care of and keep track of compensation costs. A form used for reporting accidents and injuries on the job should be simple, yet detailed enough to allow supervisors and safety officers to investigate the incident. The employee, that's you and me, is responsible for getting the ball rolling. We need to report the details of the accident to the best of our ability. That will be followed up by a report from our supervisor and the doctor if necessary. All of these forms eventually find their way into a file. That's where we have a chance to review them, come up with some statistics about the accidents, and determine what recommendations are needed to reduce the number of accidents in the future. It's also important for management to use these statistics to determine the impact of these accidents, the lost time days, workers' compensation, the replacement costs of damaged equipment, the possibility of OSHA citations, and the impact on worker productivity and morale. It gives management an incentive to maintain a safety program that keeps us all safe while on the job site. Remember, we're serving a product to the public, and we also want them to know we're running an efficient and safety-conscious water facility. Do us all a favor. Take a few minutes and fill out the paperwork, please. There are many powerful pumps in a water treatment plant and throughout our distribution system. What happens when it's time to repair these machines or when we want to add new parts to the system? Before we do anything else, we need to make sure the water has been turned off or reduced to a safe working level. That's accomplished by carefully following lockout-tagout safety procedures.
Well, if you read the papers or you look at any of the trade journals, you're going to look in there every day and you're going to see somebody in the country that has got killed because they forgot to lock and tag a piece of equipment. They made the assumption that somebody before them or somebody after them had taken that piece of equipment out of service. And you can't make an assumption when you're depending your life on it.
Lockout tagout is exactly what it implies. It's the process of using equipment that will physically prevent the energy source from being used. The flow of water in this case. Moving parts or the on and off controls are locked into place. But that's not enough. To prevent someone from removing the lock, it's also necessary to use a tag with information alerting other workers to the fact the energy source has been shut off and should remain off. The tags need to be legible and should clearly state that they are not to be removed. Both tags and locks should be strong enough to resist tampering and the environmental conditions. If there's one word that best summarizes what lockout tagout is all about, it's communication. Making sure that everyone around you realizes there's a potential danger. When the word doesn't get out, accidents can happen even to the experienced water professionals. A Midwestern water utility crew was recently working on a water main in an excavation site. Workers opened a nearby hydrant to bleed the pressure off the system on the isolated main. They called the local fire department to let them know that the hydrant would be taken out of service. This verbal notification had been used many times in the past without an incident, but it didn't work this time. A concerned citizen called the fire department when he saw what he thought was a leaking hydrant. A firefighter came to the scene and didn't notice the water department work crew just around the corner as he closed the hydrant. A quick buildup of pressure in the line blew off the fittings on the repaired main. 3 workers in the ditch were injured, 2 severely, when water and pipe materials struck them. During an internal investigation, the water department discovered that although out-of-service tags were used on hydrants that were broken and in need of repair, they were not always using tags while crews worked on distribution lines. The utility immediately began marking out-of-service hydrants and scheduled meetings with local fire departments to discuss the procedure. There have been numerous other incidents or near misses at water utilities, including those in water treatment plants when pumps were not properly locked and tagged out and water suddenly flowed into filter beds or storage areas under repair. And injuries have also occurred during the maintenance and repair of pumps and valves in a plant's distribution system when they have unexpectedly become energized. There are a number of lockout tagout programs in place for energy and electricity, and following an appropriate lockout tagout program isn't just a good idea, it's an OSHA requirement.
Hurricane season's nothing new to Floridians, but no one expected the severity of the 2004 storm season. Hurricane Ivan, the season's strongest storm, reached Category 5, the most severe classification for hurricanes, as it powered through the Gulf of Mexico, striking the central Gulf Coast. Bracing against the hurricane's strong leeward side winds, the Escambia County, Florida's Emergency Operations Center was activated. They are the center of emergency response for city, county, federal agencies, and local utilities. While local residents boarded up homes and evacuated, utility staff completed final preparations.
All of our storage facilities are topped off and valved off to help maintain pressure. Of course, all of the chemicals and things that are used at the well sites are topped off and make sure we have plenty of everything on site.
When the storm abates, utility crews eager to begin recovery efforts faced a number of challenges. Power was out throughout the Gulf Coast. The Interstate 10 bridge and other bay bridges fragmented, cutting off outside help and isolating communities. One of the first tasks was to survey the water and wastewater systems to evaluate the extent of the damage. Along with numerous broken mains, well site generators needed fuel and service had to be maintained to critical customers, including area hospitals. Another challenge faced by utility crews was lack of communications. With wireless communication towers down, state-of-the-art was replaced by the resilient analog low-tech single-channel radio system. The ECUA gained valuable insight in preparation and recovery efforts. Here are some of their recommendations. Using GIS and GPS technologies, mark and record infrastructure. Know where your valves, fire hydrants, and meters are located before an event. Maintaining communication is vital. Cell phone towers fail, so backup communication is essential. Consider battery or truck-powered analog radios, or even shortwave ham radios. Along coastal areas east and west, utilities have repeatedly endured powerful storms and have learned important lessons. Here are some additional suggestions for dealing with natural disasters. Using GIS with GPS location information, prepare a distribution system backbone map, displaying large diameter distribution mains or sewer trunks, including pipe sizes, valve locations, and other critical information. This is especially important for events that can violently erase or rearrange local landscape topography. Maintain up-to-date drawings and specifications of critical equipment, particularly long lead time manufacturer restoration units such as electrical switchgear and motor control. Maintain critical spare parts for rebuilding equipment that cannot be quickly replaced. Also, keep a list of critical resources required to maintain operations like treatment chemicals, vendor lists, originating resource locations, and alternative sources. Make sure that your utility is a signatory member of the Water Wastewater Agency Response Network. WARN is a volunteer-based utility-to-utility network that prepares for disasters, then lends assistance. Early WARN pioneers understood that restoring water was critical for maintaining basic life support services like fire suppression and hospital operations. The National WARN Initiative was launched in 2006. WARN's growth into a national intrastate organization has greatly benefited communities in need as they have responded to natural disasters across the country ever since their inception.
Controlling traffic at a worksite means giving drivers plenty of warning that a change is coming up, helping them understand where to go, and then guiding them back into a normal traffic flow once they're past the site. Here's a bird's eye view of the 5 traffic control zones that you need to consider when preparing a site. These are the advance warning area, transition area, buffer area, work area, and termination area. The first zone is the advance warning area, where drivers get the first visual indications that they'll be encountering a work site. It's also where they should begin to slow down. A series of signs in this zone should let oncoming drivers know there's a project in front of them. Distances between the first sign and the transition zone will vary significantly depending on the speed of traffic or unique characteristics like curves and hills. On highways, the first warning sign may appear half a mile or more before the transition area. The next area is the transition zone. It's where traffic is moved to one side or the other, or from 2 lanes down to 1. The minimum width for lanes from this point on is 10 feet, but a width of at least 12 feet is recommended. Be sure and advise drivers of significant width restrictions well in advance of the project, as some vehicles may require an alternative route. In this area, cones, signs, and barricades are placed to steer traffic in the proper direction. Cones should be placed close enough together so that drivers won't try to drive between them. This is also the area where drivers first encounter workers at the work site controlling traffic. Flaggers help direct traffic and identify and signal drivers who have not reduced their speed appropriately. Let's take a moment to discuss the role of flagger in traffic control. Don't underestimate the importance of the flag person. This person is critical to the safety of the entire work crew and to all drivers entering the area. This person should have a thorough understanding of the project and be trained for traffic control. The flagger should be properly outfitted in reflective highway safety clothing, including a hard hat. The flagger should be positioned where drivers can clearly see the person, not partially hidden behind trucks, trees, or signs. Keep your signals consistent and easy to understand. For example, if you are using a stop and slow sign or a red flag, use your other hand to stop or wave drivers slowly through the areas. Don't wave them through with the flag or sign. It may confuse them. Also, make sure other flaggers and work crew members understand your signals so they can anticipate what vehicles will be doing. In cases where traffic narrows to one lane and a flagger at each end is necessary, coordinate the flow with two-way radios or predetermined hand signals. Stay alert. Don't listen to music, read, or talk with other crew members while on the job. Concentrate on the traffic. Never leave the flagging position unattended. The crew foreman will coordinate lunchtime and rest periods. And always plan an escape route to make sure you can get out of the way of traffic or equipment and notify workers in the immediate work area during an emergency. Hot work is any activity that could produce flames, sparks, slag, or other hot fragments that might act as an ignition source to flammable materials in the area. Hot work also includes any activity that could generate smoke or heat to activate a fire alarm. There are a number of hazards that may exist during hot work, including fires, explosive reactions, leaking compressed gas containers, and for the utility worker, heat stress, burns, electrical shock, the breathing of dangerous fumes, and the possibility of eye injuries. The hazards of hot work don't just impact the employee who is working on the project. Hot work hazards impact other employees or anyone else in the vicinity. It's impossible to eliminate all of the dangers associated with hot work, but you can reduce the risk. We often talk about making sure you have the right personal protective equipment while working at the water utility. With hot work, the proper PPE is critical. Consult the MSDS for the specific job and materials you are working with. But here are some general guidelines. Because of the sparks and fire hazard associated with hot work, all clothing should be fireproof. It starts at the top. Some type of head covering will keep sparks from landing on your hair or falling down your neck. The choice between goggles, a face shield, and a tinted lens will depend entirely on the type of hot work you are doing. But the goal is the same, to protect your eyes. Eye injuries occur from intense light, ultraviolet, and infrared rays emitted while cutting and welding, and also from flying sparks and hot slag. Goggles protect your eyes, and many have lenses you can replace when necessary. Goggles are attached firmly around your head so they can't slip off while you're working. A face shield or hood provides more protection than goggles since it covers your entire face. Face shields are also easier to pop up and out of the way if you need to use normal vision. Face shields come in both clear and tinted styles. Whether you are using goggles or a face shield, make sure you have the proper filtering lens for the cutting or welding that's taking place. For example, soldering requires a shade of 2. Light cutting and brazing requires a shade of 3 or 4. Gas welding, about a 6 or 8. A number 10 shade is used for general welding up to 200 amps. Higher current welding, such as TIG welding, requires darker filters such as 12 or 14. Never use goggles or a face shield if they are cracked or scratched because it can distort your view. And while on the topic of eye protection, you also need to protect anyone near you from ultraviolet burns to their eyes. Even at a distance, if you can see an arc weld flash, it could burn the unprotected eye. Shield it, screen it, and warn anyone around you that you are about to strike an arc so they have a chance to look away. The ultraviolet rays can also burn your skin, so wear long-sleeved overalls, shirts, and pants. Button up your shirt collar to keep your neck and throat from getting a burn. Leather aprons, jackets, and pants specially designed for welding are the best protection from burns. Keep all of the clothes you use for hot work clean and free from oil or grease so they don't ignite and burn. If you aren't wearing a special welding outfit, be aware of cuffs and pockets on your shirt or trousers since they can catch and hold hot sparks as you work. The same goes for your shoes. Low-cut shoes allow sparks to end up inside the shoe. Also, be sure your shoes or boots are heavy-duty enough to keep sparks from burning through the shoe top. Most of the workplace accidents we experience at water utilities can be avoided if we concentrate on the basics of safety. Nothing is more basic than the equipment we wear to protect us while on the job. Personal protective equipment, or PPE. PPE includes all clothing and other accessories designed to create a physical barrier against workplace hazards. PPE is designed to protect the eyes, face, head, respiratory tract, and body extremities from potentially hazardous conditions. The basic element of managing a safety program is an in-depth evaluation of the equipment needed to protect employees against workplace hazards. This creates standard operating procedures for personnel. The next step is to train employees on the protective limitations of PPE as well as its proper use and maintenance. To ensure maximum protection, all equipment must be properly fitted and maintained in a clean and serviceable condition. Most utilities provide basic PPE for workers. Each person is responsible for maintaining his or her equipment and making sure it is available when needed. As we discuss the various types of PPE, it should be noted that these aren't just utility recommendations. Most are OSHA standards and requirements. Let's start at the very top. Head protection. Head injuries are caused by falling or flying objects or by bumping the head against a fixed object. Hard hats resist penetration of an object, absorb the shock of a blow, and are also used to protect against electrical shock. Metal hard hats should never be worn near electrical equipment. Hard hats absorb the shock of a blow to the head by utilizing the specially designed headband and crown straps that keep the shell away from the worker's skull. This is why it's important to always wear a hard hat in the correct manner, not backwards or adjusted improperly. If you share a common hard hat with others, make sure that you adjust it for your needs each and every time you put it on. It's important to know and select the right hard hat for the right job. Class A hard hats are for general service and have limited voltage protection. Class B, used by electrical workers, have high voltage protection. Class C hard hats are designed for lightweight comfort and protection and have no voltage protection. The type of hard hat is found on the inside of the shell, where the manufacturer, ANSI designation, and class is listed. Some regulators and employers do not allow paint or stickers on hard hats. If stickers are used, they should be kept at least 3/4 of an inch away from the edge of the helmet to prevent the sticker from acting as a conductor between the outside and inside of the shell. The area covered by stickers should be kept to a minimum to allow for a thorough visual inspection of the shell. The shell, headband, and all components of a hard hat should be inspected daily for signs of dents, cracks, penetration, or other damage. A simple field test involves compressing the shell from the sides with both hands and then releasing. The shell should spring back to its original shape without any signs of brittleness or deformation.